So this is where we left off on the first video. Now we'll mill the slot and trim the head of the screw to length in the mill. Okay, we're going to use a collet chuck like this one in the we're going to put it in the vise here. I'm going to use a 1/4 inch collet to hold the part. It's a little bit hard to get these things in here. This is what they call a dead length collet chuck. The collet doesn't actually get pulled back in this kind of chuck. I got to get a wrench that fits that, but the back of the collet chuck pushes forward, so the collet never changes its location. Like a normal collet chuck, like what I just used in the lathe, actually pulls the collet back to tighten it. This one actually pushes forward, so the collet doesn't move. The inside sleeve moves to close the collet, which is kind of nicer because then the part doesn't shift back and forth due to diameter changes. Because if the diameter changes in a regular collet, and it pulls back further in the taper, it moves the collet in an axial direction. This can cause problems with the length of a part or something like that, or the shoulder or whatever it makes up on. So that's what we're going to use. We're going to stick it in the vise on parallels. I got to get the parallels out. Okay, we have the collet chuck in the vise on parallels tapped down. Now we got to establish the part 0 of the part. We're going to probe the X and the Y and the Z for our fixture offset here on the machine. So I already got the program made here in the MDI. So we've got to go. Let's see how this works here. So first we're going to do the X axis. Let's start. Okay, now we got to jog it. Jog it down in Z a little bit so I can get the Y. Go Y, it should go to the plus side with this, if I did everything right. Okay, we gotta jog it back up for the Z here. Make sure it's on center line. Now we've got to go through actually making this little program to cut this to face the screw off and to cut the slot through it in this case. So first we got to get this in a position. We could position it in the CAM software, but it's easier to do it here. So what I usually do is go to a new design, and then I select this solid and copy it and then paste it in a new design so it doesn't change anything in my original model. And then I go here and I select the whole thing, and I want to move it and we'll move it up in the, well actually see, we have it positioned, we have to rotate it -90 in this case, and then we got to position, we'll select it again and we'll position this up to the Y0, and this center line up to the 0 point that way, and then we got to select the face as the point of origin for the movement, and then we got to bring it up to this point. And let's rotate it -90. So this is more or less the way we have it positioned on the screen, on the machine right now, with our x-axis pointing off to the right and the y pointing back to the back of the machine and the z upward. And now we can save it in a format that we can bring into the CAM software, which in this case I'm going to use an ASYS format, and I got to save it to where I want it here, which is I don't remember where I'm doing this thing now. There. We'll call it ZREW milling, and G. We'll just call it that, screw milling. Okay. Now we got it there. Now we got to open up the CAM software, which is Spree. Is what I use. And this is the Haas TM1. Okay. Template, I guess you call it. And then we got to open the what did I have it on? I had it on this Samsung drive in that. Okay, right here. Okay, so this is positioned just the way we want it already. Otherwise, you could position it here, but it's actually easier to do in the CAM software. So let's put this solid on. I don't have a layer for that. Let's call it the model layer, MODEL, model, and let's put the solid on there, just to organize things a little bit here. And let's select the geometry and put some wireframe geometry on this. So we got to smash it in this software to wireframe like that. Okay, that's going to help us out in order to do the well, you could define it off the solid, but it's this simple milling you can do off the wireframe almost just as easy here. So what we want to do is we want to select, we'll select this element here, and we'll make for our facing, we're just going to mill along the face of this with an end mill. So we'll select that, and we'll make a contour for that, or a chain they call it in this software. And then we'll select this, and we'll also make a chain on that segment. We'll name these SLOT for the slot, and this is the face. Just so we can keep track of what we're doing here. Okay, now we got to find some tools. End mill. No, we'll call it number 1 here, just for a description. 0.5 for flute. CARB, carbide. Call that on number 1. Flood, we'll leave that alone for right now. Put it over here, 0.50 for flute, carbide. Some of this stuff isn't really that critical. What's that holder diameter? Maybe about 1.5. And we'll say
4.5 and sticking out maybe 1.5. All that really doesn't matter too much. This is what really matters, is on this setup you put the size of the end mill, a 1-inch cut length, 4 flutes, and that's good enough for the end mill. Oh, we do have to mount it in the spindle. Okay, then new milling tools, we got a slot mill. We call this number 2, just for a description, 0.5 by 50 thousandths wide. Tool number 2, and we got 0.50 by 0.05 wide. We'll call it a woodruff. RUF. It's not really exactly a woodruff cutter, but we'll call it that. 0.5, 0.05, thickness, corner radius none, number of teeth, I don't know how many teeth that thing has. We'll say 8. I think it's got 8 teeth. Shank diameter is 240, and it's sticking out of the tool holder, oh, I don't know, 1.25, something like that. Just trying to keep this as simple as possible in order for it to do the machine work. Now we're going to establish this facing cut. First we could define some stock here. I could have done that in the CAD software, drawn a piece of stock. Didn't do it, but we'll do it here. All we need is a simple cylinder, 0.1875. No, the inner radius 0, xy, y is, we'll call it minus 0.020, give it some stock, and the center there, and then we'll go 0 and x, 0.5, just to get it some stock. We don't care about the screw end of it because we're just machining this end. And 0. Let's make it this color over. Let's select that color over there and add it. Let's just see if that looks like it's approximately where it's supposed to. Okay, that looks good. Now let's cut the face off. They're just going to take one cut across here. We're going to have to lower it down below this slot. We're just using that piece of geometry as our profile to program to. Basically, it's a, we'll call this FINISH face. Finish face. We'll select that tool, and we'll turn 3000 RPM and 0.002, 24 inches a minute. Plunge at 50. Plunge rate's not going to matter because we're not going to even do a plunge rate. We're going to wrap it down. Total depth of, we'll say 0.18, because we're going deeper. We've got to go down deeper than the cut. Incremental depth, that doesn't matter. Starting depth, that doesn't really matter either. And lengths, 1 inch clearance. I'm going to put a 2 inch because of that collet chuck on there, and we're going to wrap it down and feed over. And distance is alright for here for the lead-in type of 0.265. Well, one thing we're going to do is check to make sure we're putting. We're not going to offset the tool radius, but we are going to have left-hand cutter comp. And that's 50% of the cutter over. Let's try that. Oh, we don't need 2 passes. What are we doing here? Oh, 0.5. Okay. We could probably 0.150. Let's try that. That ought to be deep enough there. So let's just see what that looks like. Can't see it from there very well. Coming down over face the end off. Okay. That's good. Now cut the slot. 50 thousandths, and this slot was 80 thousandths wide. So we could do it in 2 passes here. So let's you gotta select that feature, and we gotta do a profiling cut, and then we're gonna select that tool. We'll still turn to 3000 RPM. I'm going to go about 12 inches a minute here. The plunge feed rate's not going to matter because we're going to wrap it down. We're going to take 1 pass at it. It'll be good enough for this slot. But we're going to set the 0. I'm going to set the start depth at 0.050 here. That's what we got to do right there. Okay. So that should be our, and we'll have to see if this collides with the stock when we simulate it here. It might. No, it's pretty far away actually. Okay, that looks about right. So now all we got to do is, we're not going to cut the chamfer on here. I'm just going to deburr it, what it showed on here. I mean, I guess I could have cut that on the lathe when I parted it off. Didn't really think about that. Put it in the program to cut that chamfer. For right now, we're just going to deburr it manually or something like that. Or we could put it back in the lathe and just knock a chamfer on it. That might be a way to go too. But this is all we're going to do right at the moment for this milling cycle. So now we got to figure out where we want to process code to. So process the code. It should be a relatively simple program. See what we got going here. Kind of probably in the way of the camera here. So that's that. What we wanted to do is be able to sit this point in there and tighten it up, which it looks like it does. See how close we got to the center line? Too bad. Too bad. Should be 80 thousandths wide. Pretty close. Okay. Oh, and also the 200 thousandths long, right? 201. Then 1,000. So all the parts are finished machined now. Cut the length. Slots milled. I went back to the lathe to chamfer the top corner to make it look nicer. So if you found this helpful, or if you even liked it, why don't you click on subscribe? And really, thanks for watching.